Welcome students, welcome to this thermal engineering session. So this session we are going to see about the part 3 of classification we are going to see about the Loeffler Boiler. The salient features of Loeffler Boiler. The novel feature of the Loeffler Boiler is to evaporate water solely by means of superheated steam. The furnace heat is supplied only to economizer and superheater. So in other words, the steam is used as a heat absorbing medium. The major difficulty experienced in Lamont boiler is deposition of salt and sediment on the inner surfaces of water tubes. The deposition reduces the heat transfer, ultimately the generating capacity. So this difficulty was solved in the Loeffler boiler by preventing the flow of water into the boiler tubes. And the feed water is evaporated in the drum using part of the superheated steam coming out from the water heater. So thus only the dry saturated steam passes through the tubes. The poor feed water can therefore be used without any difficulty in the boiler, which is great advantage of this boiler. Let's see about the economizer of Loeffler boiler. So the feed water from the tank is supplied to the economizer by feed pump. So this is the feed pump and this is the economizer. From the hot well, the feed water is fed to the economizer through this feed pump. So in the economizer, the feed water is made to flow through a number of tubes surrounding which the hot gases leaving the furnace pass over. So there is a heat exchange from the hot gases to the feed water which is preheated in the economizer. So here this is the layout of the Loeffler boiler. So this is the grate and this is the main boiler chamber. So from the hot gases which is leaving to the atmosphere, before it leaving to the atmosphere, it is passed through the economizer section, so that the feed water get heated, get absorb the heat from the pass over the gases, so that the in the economizer the feed water get preheated before it going to the circulation. Then comes the evaporating drum. It is housed away from the furnace. Okay, so it is housed away from the furnace. This is the evaporating drum. So it contains a mixture of steam and water. The feed water from the economizer tubes enters the evaporator drum, into which is also passed two-thirds of the superheated steam generated by the boiler. The superheated steam gives its superheat to the water in the drum and evaporates it to saturated steam. So when the preheated feed water comes through the economizer and then goes to the evaporating drum, and in the evaporating drum, the same superheated steam also come into contact. So these two are getting mixed, so that the heat from the superheating steam it gives to the feed water, so that the feed water becomes evaporated into saturated steam. And the mixing nozzles. The nozzle distribute and mix the superheated steam throughout the water in the evaporator drum. In this evaporator drum, there is a mixing nozzles is provided. This mixing nozzles is used to distribute and mix this superheated steam throughout the water in the evaporator drum. And the circulating pump. So this is the circulating pump. This steam circulating pump forces the saturated steam from the evaporator drum to the radiant superheater. Okay, to the radiant superheater through the tubes of the furnace wall. So this is the radiant superheater. Okay, this is the radiant superheater. It means direct the radiation of the heat, it goes to the tube surface. So this steam circulating pump circulate or forces the saturated steam from the evaporator drum, from this evaporator drum to the radiant superheater through the tube of the furnace valve. Next comes the radiant superheater. So this is the radiant superheater. So this radiant superheater is placed in the furnace. So the hot gases in the furnace are used for superheating the saturated steam from the drum. So this hot gases inside this furnace is used for superheating. Inside this tube, the saturated steam is flows inside, so that using this hot gas, this tube get heated. It make uh, it then converts the saturated steam to superheated steam. So the radiant superheater receives heat from burning fuel through radiation process. Then comes the convection superheater. Here it is the convection superheater. So then steam from the radiant superheater enters the convection superheater, where it is finally heated to the desired temperature of 500 degrees Celsius. Okay. So this convection heat superheater where it is finally heated to the desired temperature of 500 degrees Celsius. The convection superheater receives heat from the flue gases entirely by convective heat transfer. Okay, this convection heat transfer gets heat from the flue gases because this flue gases passes through this passage from the flue gases entirely by convective heat transfer. Both radiant and convection superheater are arranged in series and in the path of the flue gases. So this is the radiant superheater and this is the convective superheater. Both are connected seriously and are arranged in the path of the flue gases and the steam outlet. About one third of the superheated steam from the convective superheated steam from the convection superheated passes to the steam turbine, while the remaining two-third is passed on to evaporated drum to evaporated the feed water to saturated steam. Okay, so this 1 by third of steam to so here the 1 by third of the superheated steam is goes to the steam turbine and the remaining 2 by third of the steam to the evaporating drum. And what is the capacity? The capacity of this Loeffler boiler is about 100 tons per hour of superheated steam generated at the pressure of 140 kilogram force per square centimeter and at a temperature of 500 degrees Celsius. Let us see the animation of the Loeffler boiler, how it is working. So feed water from the hot well through feed pump, it goes through the economizer. So where it is getting preheated through the flue gases heat. And from this economizer, this hot water flow, is preheated flow, it's enter into the evaporating drum. Okay, it's entering into the evaporating drum where the superheated steam is mixed in the evaporating drum so that the feed water preheated water it becomes saturated steam. Then the saturated steam enter into this radiant radiant superheater, which is inside the furnace. And from the radiant superheater, that heated water is enter into the convective superheater. Where in this both the radiant and convective superheated, the saturated heated steam is converted into superheated steam. From the convective superheater, one third of the steam is going to the main turbine. Okay, and the 2 by 3 of the steam is going to the evaporating drum. And when it runs the high pressure turbine, the remaining blood from the high pressure turbine again comes to the reheater session, and then it go to the steam. Then the steam is going to the low pressure turbine. You can see the flow passage of the steam flue gases. So this is the flow passage of the flue gases. The same flue gases, it heated the radiant superheater and goes to the convective superheater and goes to the steam reheater and go to the economizer. So this heat, the waste heat from the flue gases, it utilizes in these three places, where in radiant superheater, convective superheater, steam reheater, and the economizer section. Now comes the Babcock and Wilcox boiler. So this is the layout of the Babcock and Wilcox boiler. So what is this Babcock and Wilcox boiler? Babcock and Wilcox is a water tube boiler. Is an example of horizontal inclined tube boiler. It is also a high pressure boiler. Construction. This Babcock and Wilcox boiler with longitudinal drum. It consists of a drum connected to a series of front end and rear end header by short riser tubes. To these headers are connected as a series of inclined water tubes of solid drawn mild steel. The angle of inclination of water tubes to the horizontal is about 15 degree or more. So let's see the working of the Babcock and Wilcox boiler. Through the fire door, the fuel is supplied to the grate where it is burned. So this is the fire door. So through this fire door, the fuel is supplied. Either the coal or firewood or anything, the fuel is supplied to the grate. This is the grate where it is burned. The hot gases are forced to move upwards. So the hot gases produced in there forced to move upwards between the tubes by baffle plates provided. Okay, these are the baffle plates. So between the tubes, the hot gases are forced to move upwards. So the water from the drum, this is the drum. The water from the drum flows inclined through the inclined tube, through the inclined tube, through the inclined tube via downtake header. Okay, so this is called the downtake header and goes back into the shell. Okay, and again it goes back into the shell in the form of water and steam via uptake header. So this is uptake header and this is downtake header. So from the drum the water is coming down, through this inclined tubes through the downtake, and again the water is going back to this shell through the uptake header, and now while going back it becomes a water and steam. So the steam gets collected in the steam space of the drum. So the topmost part of the drum is the steam, the space used to collect the steam. The steam then enters through the anti-priming pipe. So this is anti-priming pipe. The steam then enters into the anti-priming pipe and flows in the superheated tubes where it is further heated and is finally taken out through the main stop valve. This is the main stop valve and supplied to the steam turbine or steam engine when needed. So it means when the steam is collected in the drum, again it enters into the anti-priming pipe where it is entered into the superheater where the steam is converted into superheated. Then it goes to the steam stop valve, the main steam stop valve, and it goes to the and it's supplied to the steam turbine or steam engine when it is needed. So let's see the animation of the Babcock and Wilcox boiler, how it is working. So when in the grate where the fire is producing through the fuel, so that it produces the hot flue gases, the hot flue gases is forced to rise up and it mixes inside the tubes, and the water from the drum is coming down through the downtake header and then it flows up through this inclined tubes where this where the water get heated, so that the water and steam get enter into the drum through the uptake header. Okay, through the uptake header. Okay, then here the steam and water mixture is there, and the topmost part the steam is getting collected, and the bottommost part water is getting collected, and the steam from the drum it's enter into the anti-priming pipe, so that it enter into the superheater. This is a superheater, so that this normal saturated steam getting receiving heat and become the superheated steam, and it goes through the steam stop valve and supplied to the steam turbine. So this is how this Babcock and Wilcox boiler is working. And thank you students, thank you for this session. Let's see, in this session we'll see about the Loeffler boiler and the Babcock and Wilcox boiler. Thank you. Let's see in the next class.